Alright, so we have to draw the Lewis dot structure for ClO3-. Now the first thing we want to do is we want to figure up our valence electrons. And if you want more information about this, you really should look at my video tutorials on drawing of Lewis dot structures. You'll find them in the same folder. And so valence electrons, we've got 1 chlorine, so that's 7 valence electrons. And we've got 3 oxygens, and that's going to be 6 valence electrons for each of those. And then we'll have a negative charge here, which is going to lead to 1 extra valence electron. Now remember, for any extra charges here, the negative charges, we add in 1 electron. So if it was -2, we'd add in 2 electrons. If it was positive, we subtract an electron. But we're going to add that electron because it's negative. So that's going to be 7 plus 18 is 25 plus 1 equals 26. So we've got a total of 26 valence electrons to play with in this case. So what we do is we'll put our oxygens around our chlorine. Then we will bond our oxygens to the chlorine. We'll use 6 valence electrons so far. That means we've got 20 left. What I'll do is I'll satisfy the oxygens on the outside. And now that one now has 8. I'm going to add 6 to this one. It now has 8. And add 6 to this one. And it now has 8. So we've used a total now of 24. If you count them up, you'll see that each of these oxygens has 8 if you include the 2 electrons here, which are shared with the chlorine. So we have 8, 16, 24. Now that means we've still got 2 electrons left over. We can't put them on the outer atom, and it looks like the inner one still needs to have 8, so we'll put the extra 2 on there. So now you can see that the chlorine here actually is now satisfied. It has 2, 4, 6, 8 electrons, so everything is happy. The last thing we want to do here is just put some parentheses around it, put a negative charge on the outside because it was negative to begin with. You don't need to do this if it's not a charged species, but if it's charged you need to put these brackets around and put the negative on the outside. So the questions here are how many double bonds are present? There are no double bonds present. Those are all single bonds. So the answer there is 0. And the other question was how many lone pairs or non-bonding pairs are present? Well, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and that would be 10. So there would be 10 present.